You know, it's funny. Connecting a new smart speaker at home is a piece of cake, right? But have you ever stopped to wonder why turning a giant, sprawling factory into a smart factory is such an incredibly difficult job? Well, today, we're pulling back the curtain on this unseen revolution that's happening right now, on factory floors, on oil rigs, even in hospitals. It's the story of how decades-old machines are finally learning to talk to the cloud.
I mean, it really all boils down to this question. If your fridge can tell you the weather, why can't a massive stamping press from, say, 1985 tell you when it's about to break down? The answer, it turns out, is fascinating. It lies in a really deep technological divide and a whole new set of tools that were built specifically to bridge it.
So here's how we're going to break it all down. First, we'll dig into the factory's language barrier. Then, we'll meet the amazing piece of hardware that acts as a translator. After that, we'll see how artificial intelligence gets packed into these tiny devices, look at the incredible results people are getting, and finally, we'll take a peek at what's just around the corner.
To really get this, you have to understand that factories basically live in two completely separate worlds. Out on the factory floor, you've got what's called operational technology, or OT. And then, back in the server room and up in the cloud, you've got information technology, or IT. And the problem is, for a very long time, these two worlds just haven't spoken the same language at all.
And the real difference, it just comes down to their priorities. OT is all about reliability. Its one job is to keep that machine running 24/7, no matter what. It's built on old but absolutely rock-solid proprietary languages. IT, on the other hand, is built for grabbing tons of data, analyzing it, and scaling up using all the modern standards of the web. So you've got one world that values stability above all else, and another that values flexibility.
And this, right here, just shows you the time gap perfectly. Just look at Modbus. It's the workhorse of the factory floor, and it was introduced way back in 1979. It's super simple and reliable, which is great, but then you compare that to something like MQTT, which is the language of the cloud, and it was designed for a totally different, modern, connected world. This is the language barrier we have to solve.
So, how in the world do you bridge a 40-year gap in technology? Well, you do what you always do when two people don't speak the same language. You introduce a translator. In the world of the industrial Internet of Things, that translator is called an IIoT gateway. And it's pretty much the hero of our story today. And these little boxes are the devices that make all the magic happen. They are rugged, specialized computers designed to live right there on the factory floor, bolted to a wall right next to the machines they're listening to. Their entire reason for being is to act as that multilingual interpreter between the old world of OT and the brand new world of IT. But a gateway does a lot more than just translate. It's actually juggling four critical jobs at once. First, it connects, speaking all those different machine protocols. Second, it buffers data, kind of like a safety net, so nothing gets lost if the internet connection flickers. Third, it secures the whole operation, creating a strong firewall between the factory floor and the outside world. And finally, it normalizes the data, turning a raw signal like tag 1023 equals 1 into something a human can actually understand, like main conveyor belt is now running. And we have to remember, these environments are no joke. We're not talking about a nice, air-conditioned office. As this quote points out, in places like an oil field or a chemical plant, the stakes are unbelievably high. A single, tiny spark could be catastrophic. And that is why these gateways are basically built like tanks. They often have no fans, which is huge because it keeps all the dust and grime out. They're designed to operate in scorching heat or freezing cold, and they have to carry these special certifications like ATX or UL, which are basically a guarantee that they are safe to use in the most dangerous hazardous environments on the entire planet. Okay, so we've connected our old machines. They're talking. That's a huge step. But the real revolution, the game changer, isn't just listening to the machines. It's getting them to think. The next step is to give these machines a brain, right there at the source. And this is what we call intelligence at the edge. Edge AI is pretty much exactly what it sounds like. Instead of sending this massive, overwhelming flood of raw data all the way to some distant cloud server to be analyzed, we run the artificial intelligence models directly on the gateway itself. All the thinking happens right there, locally and instantly. But of course, there's a catch. The super powerful AI models you're always hearing about, they are huge, absolutely massive. They're designed to run on giant servers in data centers. So to get one of those to work on a small, fanless gateway sitting on a factory wall, you have to shrink it, like a lot.
And this all comes down to something called model optimization. You can take a 400 megabyte AI model and actually shrink it down to just 100 megabytes. One of the coolest techniques is called quantization. Think of it like this. Instead of using hyper-precise decimal point heavy numbers for everything, the AI learns to use simpler, good enough whole numbers. It makes the model way smaller and way faster without actually losing its core intelligence. It's brilliant.
And that's just one trick in the toolkit. Engineers also do something called pruning, where they literally snip away unnecessary connections in the AI's neural network, just like a gardener trimming a bush. They even have large, powerful AIs teach smaller ones, passing down all their knowledge. The end goal is always the same. Make that AI lean, fast, and efficient enough to live right there on the edge.
Now, I want to be clear. This is not science fiction. This isn't something that's coming soon. This technology is already out there, right now, and it's delivering some absolutely jaw-dropping results in major industries. Let's take a look at a few examples.
So in manufacturing, the absolute killer app for this is something called predictive maintenance. For decades, factories have been reactive. They fix things after they break. This is a massive shift to being proactive. By listening to vibrations and sounds right on the machine, an edge AI model can actually predict a failure before it happens. It can prevent a costly shutdown before anyone even knows there's a problem.
And the impact is just massive. Companies that are using this are reporting that they've reduced their unplanned downtime by up to 40%. For a big factory, that translates into millions and millions of dollars saved, and a gigantic boost in productivity. Now, think about healthcare. Edge AI is a total game changer there, too. Portable diagnostic tools can now run AI analysis on site, giving doctors insights way faster than before. And this is a big one, because all that sensitive patient data is processed locally and never has to leave the device. It helps hospitals meet super strict privacy rules like HIPAA.
And back on the factory floor, automated visual inspection is another huge win. You can have AI-powered cameras that can spot tiny, microscopic defects on an assembly line that a human eye would almost certainly miss. And the result? Product quality can be improved by as much as 30%. And really, the applications are popping up everywhere. Retail stores are using it to track inventory in real time or create those cool frictionless checkout experiences. Smart cities are using it to manage traffic flow and make the power grid more efficient. The potential is, well, it's pretty much limitless. So if this is all happening today, right now, what does the future hold? What's next? Well, the next wave of this whole revolution is already starting to form on the horizon.
Looking ahead, we're already seeing specialized AI chips called NPUs that are making these little edge devices even more powerful. In the near future, you'll see things like federated learning, which lets devices learn from each other without ever sharing private data. And as 5G and eventually 6G networks roll out, intelligence won't just be on the device at the edge. It will be woven directly into the fabric of the network itself. Which really brings us to this one final fascinating thought. For the first time in history, we are giving a voice to the trillions of motors, pumps, and presses that build our world. As every single machine begins to speak, you have to wonder, what incredible new secrets about how to be more efficient, how to build better things, and how to be safer? What will they tell us next?